In this video, we're given a hint to let u equal the cosine of x and use partial fractions to evaluate the given integral. There could be another way, but we'll try this. So u equal cosine of x, so du will equal to the derivative cosine, which is minus sine of x, and then we have the dx. So the sine dx right here can be replaced by, looks like minus du. We can multiply both sides of this by a -1. Then I put the -1 over here. So this will be u, this will be u, and sine x dx will be replaced by du. So this would be the integral of 1 over u multiplied by u minus 1. That's a rational expression in the variable u. So we can use partial fractions. So the setup will look like this then. So let's transform this integral in terms of u. I'll have the integral, and the sine x dx, like I said, was replaced by minus du. Cosine of x was equal to u. Cosine of x minus 1, replace the cosine of x by u again. We have this right here. This will be the integral of then. We have two linear factors, u to the first and u minus 1 again to the, and that's a first degree binomial. So we have one constant over the u factor plus a second constant over the other factor u minus 1. Now for this one here, the integration is going to be pretty straightforward because we have linear factors here. So the integral for the first setup there is going to be a multiplied by the natural log of absolute u. The next integral, the next value for the next one will be b, the natural log of u minus 1. And then we make the substitution for u, which is cosine of x, plus the constant of integration, and we're done. So for the setup then there, we have minus du. Now we just simply need to find the values of a and b. So there's your setup. Now if we had a third factor here, linear factor, then we'd have a c over that. And we're going to try the cover-up method here. So here's the way it works, and we'll go over why it works in a little bit, but if you have linear factors, this method is always going to work, if they're all linear. Now if you have one that's repeated, let's say this one's to the second power, or you have a u squared over here, you can still use it, but then you have to still incorporate other methods to find the values of the constants. But here's the way it works. Let's say you want to find the value of a. You look at what's under a. That's u. Cover it up. And what makes u 0? Well, u equal to 0. So in the cover-up method, you let u be 0. In other words, ignore it. And then forget about the b for now. And just plug it in here. Put a 0 where the u is. We had 0 minus 1 is minus 1. And remember, on top we have a minus. I guess I don't need the this part here for now. It's just the numerator. Don't include the du or the dx, whatever you're working with. So if I let u be 0, like I said, this gets me -1 into -1. So this would imply that a is -1. So I know a to be, a will be +1. That's just -1 over -1. So a is +1. Now if you want to find b, you cover up the factor that's under the b. So over here you cover it. I'll just mark it out. Cover it up. And you say, okay, what makes u minus 1 0? And of course it's 1. So just ignore the u minus 1 and replace it. So get -1 over 1. So when u is equal to 1, b is equal to -1. -1 over 1 is -1. So there you have it. Now we know the constants. So where the a is, we put a 1 here. And then where the b is, we put -1. So we got that 1 over u. If this is linear, and the coefficient of this u is a 1, Same thing over here. It's always going to be the natural log, absolute value of absolute, whatever you have there. In this case, it's U. And then it's minus, so it's a minus natural log, absolute value of the denominator. Now this is a 2, it's a little bit different, or a 3, or it has a coefficient of 2 here. As long as it's linear like this, U minus 1, U minus 3, this will always work. And this plus the constant of integration. And then just go back to the original variable. Remember, U was set to equal to cosine of x. So this is just ln of absolute cosine of x. Then it's minus ln of absolute, again, U is cosine of x, so it's going to be cosine of x minus 1, plus the constant of integration. So you can give this answer right here. It's ln of the absolute value of cosine of x minus natural log of absolute value of cosine of x minus 1 plus the constant of integration. This is one answer you can give. Now, because you have a difference here, you can apply the properties of logs. Anytime you have a difference in logs, you can write it as the log of a fraction. So this can also be written as the natural log of absolute value of cosine of x over cosine of x minus 1. Those are equivalent. Your constant of integration also over here. Okay, so that's your answer. Now, just if you're interested here, just to comment on why this procedure, the cover-up method, works. Here's the same setup I just had. Normally you would set it up this way, and then you would clear the fractions and multiply through by the LCD. On the left side, you're left with -1. On the right side, you're left with a times u minus 1 plus b times u. And you could set up a system of equation here. Multiply through here and combine your u's and constants together and set that equal to the appropriate terms on the left side, and you get a system of equation. And like I said, if you have linear factors and at the same time quadratic factors that don't factor, or you have to try some other techniques, you can still mix it in with both. You treat this as an identity here. So I could pick other numbers here. I could pick, let u be 3. And what do I get? Let u be 3. This would be 3a minus a. This would be 3b. And then plug in another number. If you have two variables, you need two equations. But the cover-up method works this way. We said to get a, we replace the u by 0. And this is why it works. U equal to 0. This factor, the b's gone. And you put a 0 here, we get minus 1 times a. So minus 1, a is equal to minus 1. The negatives cancel, and you get a equal to 1. That's what we got. Now to get the b, see, the factor u minus 1 was under the b. We said replace the u by 1, because that's what makes it 0. But notice when we plug in 1 for u, that goes to 0. And then here you have 1b equal to minus 1, which tells me b is equal to -1. And that's how we got the values of a and b using the cover-up method. Thanks for watching. We'll see you next time.